I'm Frank, and this is Koshin. We're here from Epson Robots Applications team. Thank you for spending the time with us today. What you see here is an Epson LS6B Scara robot doing a common pick-and-place application. For this demonstration, we will show you how simple it is to develop a pick-and-place program within the Epson RC Plus development environment. It's easy even for those new to automation. For this demonstration, we have mounted a vacuum generator and cup to the end of arm that will create vacuum when the air is turned on. The robot is connected to the controller via USB. Let's begin. First, make sure the controller is turned on. Double-click on the RC 7.0 icon on your Windows desktop. The current robot connection list box on the Epson RC Plus toolbar should say offline. Once you are certain that the controller is ready, select the USB from the drop-down. Epson RC Plus is a Windows-based project management and application development environment for Epson robots. I'll introduce you to the various dialog screens and features of Epson RC Plus by creating a very common pick-and-place application. There'll be 2 points. One is where the part will be picked, and the other is where the part will be placed. An Epson RC Plus project is a collection of program files, robot point files, and setup parameters that are all necessary for the application. Programs are written in our own proprietary language called Spell Plus. Spell Plus language has similar syntax to BASIC. The controller uses a subset of the Spell Plus language, but still has a vast amount of available commands and options. Epson RC Plus follows a Windows-style environment, so cut, copy, and paste are all intuitive as any other Windows application. Let's create a new project. In the software, select Project, New. Let's give this project an appropriate name, such as Demo. Select Template, Pick Place 1-to-1. When you click OK, the Pick and Place template code will be automatically generated. Template creates the framework for a typical application. You must modify the code to suit your specific needs. Click on the toolbar button with the robot to bring up the Robot Manager. The Robot Manager will open with the Control Panel tab displayed. The Control Panel contains buttons for basic robot operations, such as turning on the motors. It also displays emergency stop and safeguard statuses. Turn on the motors by clicking the Motors On button. All Epson robots include an emergency stop button to stop the robot for any reason. To reset the e-stop statuses, simply select the Reset button. Bring up the Jog and Teach screen by clicking the Jog and Teach tab in the Robot Manager dialog. As the name implies, the Jog and Teach tab is primarily used for jogging the robot to a desired position and teaching a point using the current coordinates and orientation. Select the point number that you want to teach in the Teach Points control group in the lower center of the window. Jog the robot to the desired position and teach the point. Jogging distances can be changed by selecting the preset radio buttons. After positioning the robot at the pick position, select P0 Pick from the points list box and click the Teach button. That was one way to teach a point, but now I'll show you a simpler way. Back in the control panel, you can select the Free All button. This frees the joints so you can manually move the robot to the place position. I'll put a part here so we have the appropriate place height. Even though the joints are free, you must hit the brake release button here to free up the ball screw spline. Select the P1 place from the point list box and click the Teach button. The point label Pick and Place were automatically created by the template. Labels allow the code to be readable and maintainable. If you teach a point that has not been previously taught, a dialog will prompt you for a point label and description. As an alternative to clicking the Teach button, you can open the Points tab in the Robot Manager and type in the coordinates of the point. Be sure to click Save so you can retain the points. As previously mentioned, a template provides a framework for generic type of application. The code will need to be modified to suit your needs. For example, the template sets the motor power to high. Power high allows the robot to run at full motor torque. For this demonstration, we want to run in low power, which is a low speed and acceleration, as well as about 30% motor torque. Delete the power high statement and type in power low. SmartSense technology includes a color-based editor with auto syntax assist, code indent, and comprehensive source level debugger. Keywords turn blue, comments show up in green, and any syntax errors will pop up red. Epson RC Plus has a built-in help menu as well. Let's hover over a command and hit the F1 button on your keyboard to launch the help menu. This will launch a lot of helpful information on the command and as well as some sample code that you can directly copy and paste into your code. Let's break down the sample code provided in the template. The line of code that says init robot calls a function called init robot, which performs all the initializations such as turning on the robot motors, setting the power state, and assigning the speed and acceleration. There's also an infinite do loop that will continue to run until the operator aborts the application. In this loop, the robot jumps above the pick location and waits for input, which was labeled part in POS. When the input turns on, the robot moves down to the pick location, turns on an output labeled gripper. This line adds a 100 millisecond time delay for gripping the part so we can ensure the part is secure. Next, the robot jumps to the place location. Jump statement moves the arm from the current position to the specified destination point using point-to-point motion. First, the robot moves in a vertical up direction, then horizontally, then finally vertically down to arrive at the final destination point. The robot turns off the gripper to release the part and grip, increments a part counter, and prints the cycle count to the RC Plus run window dialog. As mentioned earlier, we did wire some inputs and outputs to show you. We often get asked where to find these types of documents. You can go to the Help menu, and the drop-down gives you all the manuals for both the robot and the controller. Open up the RC90B manual and go to the I/O page. The I/O label editor lets you define meaningful names for your inputs, outputs, and memory I/O for each project. The labels can be used in your program from the command window or in your macros. They're also displayed in the I/O monitor window. These can be virtual if you're working offline. To run the program, click on the Run Toolbar button. We did not actually need to modify the power statement in the code. We could have simply just checked the box in the run window to force low power. Today we have completed the demo with the live robot. However, many of our customers prefer to program offline and use the built-in 3D simulator that comes with RC Plus. This allows you to visualize the motions of the robot and perform interference checks. Tools and step files can be imported into the simulator environment. So that's it. We hope you see how simple it is to program with Epson RC Plus.